Welcome back. All right. Now we've got Beat the Rush, designing effective load tests for your web application by Anthony Shaw. Take it away, Anthony.
Cool, thank you. Okay, hey everybody. Hope you're all having a good day. I flew in this morning from Sydney. You might be able to tell from my accent that I'm not from around here. I'm actually English, so before we get into load testing, I'm going to talk about a couple of things. One is football, the second one is tea, and the third one is the Queen, and how they all relate to load testing. So if you want to follow along, this is my website, the top link. Second one is my Deadbird X account. And then I'm also on Mastodon if you're on Mastodon as well. So, load testing and T, what do they have to do with each other? So, I guess over the last few weeks everyone's gone a bit nuts with the Matildas. The last game was the most watched TV program in Australian history. Apparently 11 million people watched it. I'm originally from the UK. Soccer's not a new thing for us. We have kind of been into it for a while. There's a famous problem, and that's what happens at half-time. Now, at half-time, however many people are watching the game will go into the kitchen and turn the kettle on to make a cup of tea. Like, you might think that's not really an issue, but when you've got 20, 30 million people watching it, and they all turn on a 2 kilowatt kettle all at the same time, it effectively melts the electricity grid. The second thing they do is to go to the bathroom. So what they have to do when they know there's a big game in a World Cup is they have to test, effectively load test, two things. One is the electricity grid, and the second thing is the sewage system. Because effectively, yeah, both of them get load tested pretty hard. So England versus Italy, 2020, 1.1 million kettles simultaneously boiling. Was a 600 megawatt load. All in a huge spike. Now, we're going to talk about load testing, and I want you to keep thinking about this analogy because not all load tests look like this. One that I was involved with a long time ago was a TV soap called Emmerdale, and they were running a series in Emmerdale where you had to try and figure out who killed this particular character. And at the end of the episode, they'd say, if you want to find out more, try and figure out the clues, click on this, go to this website, and effectively we had a half-time problem with the kettles, but a website version of that. The other one I got involved with was the Royal Palace set up a website for the Queen in the unlikely situation that she passed away. There's an obituary website, and they asked me to load test it. This is a while ago, so I had to load test that site. And I think when I heard the news quite recently of her passing, I was the only person that went white in the face and immediately went on their laptop to go and check the latency of the website. It did hold up, so that's good. Okay, so when you're designing a load test, you need to think about a couple of things. Now, you need to think about the number of requests that you want to simulate, and I think about this as being like a queue of people in a line, a nice orderly queue, okay? The other thing you need to think about is concurrency. These two things are not the same. So if you say, I want to test 1,000 requests, is that one at a time, or is that 1,000 at a time? Because when you think about people and the strain that they can put on infrastructure, the right-hand side looks a bit like a stadium maybe, or a gig that's just finished, and you've got a lot of people all trying to leave an area at the same time, all trying to get on the train at the same time, so you've got a high concurrency issue. So what you don't want to do is to use a tool like Apache Bench, which is a great tool for measuring the performance of web servers but not applications, because it will effectively generate load on your website that looks absolutely nothing like real load. So the numbers that you get back, you might say to your engineering team, oh, we can handle 12 requests a second, and it's going to hold that at 800 milliseconds, which sounds great. But that load looks nothing like your actual website load. What real user patterns actually look like is this. Does anyone play this game in the room? Okay, a few of you do. Okay, so City Skylines is brilliant. Now, what real user load looks like on a website is actually quite different. You've got different users going to different parts of your apps at different times and at different speeds. So, your users are not robots. They're not all clicking on things at, in millisecond precision. They're taking their time. They're looking at things. They're clicking on stuff, and they're going in different directions. People also have different speeds of their internet connections. The latency between them and the website is also a bit different. So the reason I bring this up is because you've got people going maybe to the home page, people going to a different part of the app, and people going to the search. What you can end up with in many applications and in City Skylines is a bottleneck, where you've got users trying to go through a particular thing at the same time. So we talked about Postgres in the last talk. Sometimes the database is the bottleneck. Sometimes it's the web server itself. But if you're simulating user load instead of just trying to create network traffic, you can find these bottlenecks a lot easier. So not all users have the same speed car or the same connection. Not all users arrive at the same time. They take different journeys, and they also wait between clicks. So this is really important. So if you want to understand your users in a bit more detail, so if you want to design a load test, the first thing you want to do is actually understand your users more. What does the load look like on your current application? If you haven't launched the application, you've got to guess. So we'll talk a bit more about that. So when you're thinking about users and what they do with your app and what they do with your website, they take different paths. They'll click on different pages. Those paths, you can work out probabilities of them. You can say, okay, 60% of users will start on the home page, 20% of them will then go on the promotions page, let's say. So you can look at your web history and see what journeys do people take. And then if we want to write a load test, let's simulate that. And most of the load testing tools will let you say, design a virtual user and actually give them a path to take. So if you're analyzing the traffic first, and you can group users into personas, so you've got like a casual shopper, maybe someone who's actually going to go and place an order, then that means you can create a more realistic load on your application. There are tools that you can get as well that let you visualize this stuff. So if you're looking at your web traffic and your web history, you can actually see the journeys that people take and then how many of them go through that particular page. And once you've got that understanding, you can simulate the load a lot more accurately than just throwing requests at the web server. So another thing to take into account as well is timing. So like I said before, real users, will wait between clicks. So if you want to do a proper load test, you want to try and simulate some of those pauses. If you've got this kind of analysis where you can see the user flows, it should tell you how many seconds it takes between. If you don't have that, you could just ask a couple of colleagues to go and click through the site, and you can time them with a stopwatch if you want, or you can just guess. Having zero wait between clicks is unrealistic, and it creates really weird load, and you'll actually find bottlenecks that won't actually come up in production. So you'll try and basically prematurely optimize problems that wouldn't even exist when you're putting the app in front of users. What users do instead is, if we see this like a timeline, they'd start off on one part of the application, wait a bit, go to another page, click on something else, and then maybe they're done and they log off. So if you've got two users, they're on two different timelines. They're not synchronized with each other unless they're looking over each other's shoulder. So if you've got two people going on the website, they're going to be clicking on different parts of the site at different times. So if you want to run a load test on your application, you want to simulate some of this randomness as well. Something else which is really commonly missed in load tests is if you've got an app that does a lot of AJAX, so it's got a lot of JavaScript, some load testing tools will ignore that. So if you just make HTTP requests to the server and you simulate it and you think the performance is brilliant, then you actually launch it and you put it in front of a bunch of users, and there's an Ajax thing that polls every 100 milliseconds, and you've got 100 people leaving their browsers open, you just ignored like a huge part of the actual load of your app. So it's really important that you understand, is there an Ajax component to my application? And if there is, what difference does that make to the load that's put on the server? Okay, so the tool I want to talk about is Locust. There are other tools for load testing. I particularly like Locust for a couple of reasons. One, it's free and open source, which is always a big tick. Second one, it's written in Python. And also, it's really easy to get started with and really easy to use. So to use Locust, you just do pip install Locust. And then you run locust-f with a Locust file. A Locust file is a Python file in which you define virtual users. And basically, it uses each one of those users as a script, and it will create load based on that script. So we're going to give you a couple of examples of what a Locust script would look like. So the first thing we do is we import a HTTP user, a task, and then a function called between. And you define in a class, so you inherit from HTTP user, and you define a user. So you can call it what you like. I'll call mine basic user, because I think they're basic. And we're going to wait between 3 and 5 seconds, that's what that statement means, between each new user. So they've got 3 tasks. The first one is to go to /, which is the home page. The second task is to go to the destinations page. And then the third task is to go to the specific destination. The task decorator basically means that that method is a task, and each user will do all of those tasks. The argument 3 says that that task is 3 times more likely to happen. So actually, they're going to go to the home page 3 times more than they would to the other 2. So that's more realistic, because a lot of people just go to the home page and then realize it's not for them and then click off. So if this is our basic user, that's going to create quite a bit of load to the home page and a bit to the destination and then the specific destination page. So the between function means we'll wait between 3 and 5 seconds per task and then run that 3 times more often. I mentioned Ajax before. So we're just doing a .get. So this is a HTTP request on that URI. If you have a more complicated app, if you can't just simulate load by going to URI, there's another option, which is to use Playwright. Has anyone used Playwright in the room? Okay, a few of you. Playwright is a browser automation tool that has a wrapper in Python. What you can effectively do is, if you install Playwright, then you can run Playwright code gen and then do target equals Python. It will pop up a browser. You can go to your website, and it's recording everything you do. So you can click on the buttons, you can fill in forms, you can submit stuff, if it's in JavaScript. And on the right-hand side, you'll see that Python code window, and it generates the code of what you've been clicking on. So if you've got a complicated app, and it would be quite time-consuming and quite tedious to go and actually code how to click on all the buttons, how to find that particular drop-down, then you can just use the Playwright recorder. And then there's a plugin between Locust and Playwright. So instead of just creating a HTTP user, you can create a Playwright user, and you can give it that code that got generated here, and then it will actually open up a browser and then drive the traffic using the browser. There's a link at the bottom to a code sample of that all working. One caution I will give you, if you're simulating a large number of users on a single machine, is one thing to do that using HTTP traffic. It's another thing to do that by opening 1,000 instances of Chrome on your machine. So don't expect the same performance, because you won't achieve it. Okay, so going more specifically into Django now. Django has a brilliant feature in that it's got built-in CSRF, which is a sort of security layer, which means that you can't inject stuff into forms if you're not actually the person who did it. This creates a bit of a complication sometimes, because when a Django form loads up on the page, you need to read a hidden field, and then you need to put that in the submission when you click on a form. So if you have to do that, you can do that using basically doing a get first, and then to get the CSRF token out of the cookie, and then include it in the post request. So in Locust, when you're programming HTTP users, your tasks can include a series of commands. So not just the get to the URL, but you can actually have a get to load the page, and then another request, which is the post. Cool. So that is a sample of how to do that, and there's a link at the end of the talk as well if you need to copy that code snippet. Now, that's kind of a bit of the nuts and bolts of how to use Locust. Going back to the actual part of the design of the load test, because that's where there's a lot of common, I guess, pitfalls in terms of what you're testing and how effective that is at actually estimating whether your website's going to hold up when it hits a lot of load. So a common mistake I see is that people will deploy their application and then they'll run a load test. And the number of users they have on the application when they're spinning it up and testing it is like 1. And the number of products they've got in the database or the number of widgets they've got on the thing is like 2 or 3. And that's your test ones, right? Now, when you actually look at real load, if you've got 10,000 products in your production app and you've got 2 in your test app and you're load testing both of them, those load patterns are going to look very, very different because the number of SQL queries it's going to be running on one versus the other is going to be different. And also, if you've got pagination on your page, there's a lot of different context things. So what I strongly recommend is that you seed test data into an application or a server before you load test it. And there's a couple of ways that you can do that. There's one approach that I really like, which I'll recommend, but there definitely are others. This is to use a package called Nemesis. There's other ones like Faker. There's some other packages for generating fake data. I like Nemesis because it's really good for testing like internationalization, and you can actually test. You can create test data in different languages with different contexts and stuff like that. So it's really helpful. So if you spun up an application and you wanted to create 1,000 users in the system, you could do that just by writing a seed function, importing Nemesis, and then using this person object. That person object will generate a random name, a random email, and a random password for each one of those users. And it's got loads of other properties as well. You can put in their address, their political affiliations, their favorite type of tea, like it's got everything in there. So, and then once you've done that, you want to use a bulk create call to add all of those users in a huge batch. Cool. So here's a test question for you. What is the fastest implementation of this problem? So return 610 is definitely that's the most efficient way of implementing that function. And it's the same when it comes to web apps. So what I've often found with Django and with all frameworks, with ASP.NET, with other languages, with different infrastructure, is that often when you get a bottleneck or you get slow performance in an application, the solution is to cache. And you look at caching from the top down. So my lovely implementation of the Fibonacci function is effectively just caching it based on the answer. And actually, most good implementations of the fib function will use an LRU cache. This one's just cheeky. OK, so let's cache everything. Now, in a Django stack, you might think, OK, I've used the caching module before. So you're kind of familiar with that. Actually, there's different parts that you might want to cache depending on where the load is going to be and where you're going to see benefit. So at the top end, you've got your HTTP server. So this could be Apache, or it could be Nginx, for example. So you can cache at that layer. So that kind of cache would be like a CDN, where you've actually just cached the bytes, the HTML that's been generated. And that would look the same for everybody. You've got WSGI and ASCII. I not familiar with any caching at that level, you kind of then got the Django application from there downwards, and you've got middleware views, models, static files. Each one of those can kind of be cached using different mechanisms. So underneath that, in your middleware, you've got different middleware that you want to plug in. You've got templates, you've got the ORM, and then underneath that, you've got the database. So when we look at caching with the Django app, the whole stack of it, there's actually different places you can do caching. So at the top end, you've got a CDN or like an edge cache. So before you kind of jump in with Django and say, okay, let's cache it in the template, if the page is practically static, or the part of the site that people are mostly going to is basically static, then just cache that whole page. There's no point in introducing caching at a really low level when you could do it really efficiently at the top if the generated result is always the same. That said, if the first thing people have to do in your Django app is log in, then introducing a cache at the top is going to be pretty pointless because the page looks different for everybody. So this is kind of where you have to look at caching in terms of the whole stack and which parts will be the same and which parts will be different and where does it make sense to cache. The template caching in Django, I'd recommend that everybody uses. So you don't want it to have to build and generate the template every single time, especially for partials, if the inputs are the same and the output is the same. There's no point in computing that result for every single user that goes to the application if it can be cached. You've also got things on the database layer. Most of these you don't have to configure, but you can do, and that's kind of how things can be cached in the database. You've also got object caches you can just throw around all over Python to make things a bit faster. Cool. Now, if you have introduced caching, there's another pitfall you can fall into, which I'll talk about, which is you design your load test, and in your load test, you said, okay, we're going to get destination number 1. And you've tested it, and it works brilliantly, and you ship it to production, and it performs horrendously. And you're like, but I tested it. The locations page was really fast and really efficient, and then when we shipped it, it wasn't. Like, what's the difference? And the difference is that I hard-coded the ID 1 in my load test, and it cached the hell out of that page. And then when we ship it to production, we've got it running across 10 different servers with 20,000 different destinations, and people are clicking on different ones, and the cache isn't preceded, so the performance is terrible. So if you can, try and introduce an element of randomness to your load tests, so you're actually testing different instances or different IDs. This is across both if you're looking at individual records or if you're inputting data. Basically, try and simulate as much as you can the randomness of a user. Not all of your users are going to go and click on the same page. And if that's what that looks like, then try and test your cache. OK, so if you've got all this working and you run Locust, you're going to get a graph maybe that looks a bit like this. And I'll tell you a bit more about how to interpret the results. So often what you see with most applications is, so we've got 2 lines here. One is the median response time, and the other one is the 95th percentile. The 95th percentile means that 95% of responses are less than that number. So often when you're looking at performance data, you look at percentiles. So you try and ignore some of the outliers, and you say, okay, what performance will most people see? And because the word most is subjective, you can pick a number, but 95 is pretty typical. 99 would be extreme, so I'd say 95% is normally what you should be looking at. You'll see a spike often at the beginning because things are warming up. So that part is effectively a warm-up of either the cache, the server, the instances. You know, there might be some processes which were asleep, and all of a sudden you're throwing thousands of requests at them. So it takes a minute for them to warm up. So the line after that, if you see a nice flat, stable line for your load that you generated, it means you're looking pretty good, and you've got a stable application with no obvious bottlenecks. In Locust, you'll also get detailed information about the specific URLs that you've called, and then what the average response times were and what the percentiles were. Generally, you can ignore the average or the mean because the 95th percentile is a much more accurate representation of what people will see. So if you're looking at this data, often you get really weird outliers because of the network or because it was just booting up. But once it's out and it's stable, that's the number you want to be looking at. Okay. So something else you can do in Locust is you can set a ramp. So you can say, okay, we want to get to 1,000 users, virtual users, but they're not all going to go and start at the same time. So we're going to slowly introduce more and more users. So one of the options when you start Locust is what ramp time do you want to have? So if you slowly introduce 5-10 users at a time over a 5-minute period or over a 1-minute period, that is a lot more gentle on your application and is a lot less likely to introduce bottlenecks which are synthetic. They're not real. Because unless, that is, you're trying to load test what happens if people will go and click on the website at the same time. If you've got the census, does anyone remember that dilemma with the census, right? Oh, who could have predicted that everyone would leave it to the last minute? Yeah, unless we told everyone to do it at the same time. So if you've got that type of application, or you're running a quiz for a soap opera where you go and tell everyone in the advert, which airs at the same time, to click on the website, then don't do this. But otherwise, you can slowly ramp up your users. The thing that you're trying to look at in your graph, which is the response times, is where I've pointed the arrow. So we saw we had a nice sort of stable response time in the 95th percentile, and then all of a sudden, when I got to a certain number of users, which was 190, then the response times start to creep up. What that's actually showing me is that around 190 users, there's some sort of bottleneck in my application. So when you're looking at Locust results, if you see a stable line, that's good. If you see at some point it starts to climb upwards, there's some sort of bottleneck. Locust isn't going to tell you what the bottleneck is, it's just going to tell you there is one. So we can see the response times increasing. So somewhere there's a queue being introduced. So if this is city skylines, we see traffic jams. In real applications, somewhere there's a queue. It could be the database, could be the network server. It's hard to know, but you know there is one. So once you've got that, then you can start doing profiling, which is a completely different talk. And I'm not going to tell you how to do that. So yeah, hopefully this gives you a good introduction to load testing with Locust. You can download Locust and test it out. If you find it too cumbersome to write all the HTTP requests using that method, then I recommend giving the Playwright one a go and using the Playwright user, and then you can record tests in your browser. Playwright's also got the benefit that you can export it as PyTest, as a PyTest test file. So not only are you generating a load test, but you can actually generate a UI test as well. So if you go in and you click through the website and you click on the buttons and you check that that button is still there and it's not over there, you can, in the drop down in the code generator I showed you, PyTest is one of the options. So you can save that and you can just run it in PyTest. Introduce that into your CI/CD, and now you've got automated UI testing. So win-win. Cool. So in conclusion, start by analyzing your users, if you have any. If you don't, then pick some friends and get them to test the application and see what they do. Try and vary your inputs, so don't hard code everything to one. Vary the timing, the user requests, and the data, because users are random, so you've got to try and simulate some of that. And remember, keep remembering the goal is to simulate real user traffic. That's what you're trying to do. Beware of false performance from caching, which I showed you. So that kind of comes back to the randomness element. And optimize when you finish this. So once you've got a good benchmark, you know what the Locust results look like. Once you've got that, then you can jump into your application, start introducing caching, start increasing the number of servers you have, or whatever it is. And then you've got a baseline. Run the same test again, and then compare the results. Locust actually lets you do side-by-side comparisons as well. So if you need to go and demonstrate to whoever it is, the engineering manager or colleague, that you want to make this change, and if we make that change, it's going to mean, the app runs faster for 100 users, 1,000 users, whatever, then it's good to prove that. Cool. All right, thank you very much.